Hello everyone, welcome to EduRev. Today we are going to unwrap the topic real numbers as you can see on the screen. Now this chapter is so interesting and easy to learn. It can fetch you marks in a very easy way. This chapter deals with a lot of topics that are interconnected with various concepts that you have studied in your previous classes. But before moving and diving into the chapter, can you people answer one question of mine? And that question is that what exactly are these numbers? Like what numbers, or I would say like why numbers? Now you people must have noticed one thing, that we require numbers for almost I would say each and every task that we do. Like for example, if you go to a shop to buy fruits, then at that point itself you want what? Numbers. So as to do what? Maybe like to do counting. Like for example, if you want to buy bananas, then you need to count them. For example, if 12 bananas are of, let's say 70 rupees, then how much you have to pay if you want to get 6 bananas? So for this calculation itself, you need what? Numbers. And not only this, for equations itself, you need numbers, right? For example, there is this girl whose name is Jessica. And there is this boy whose name is David. Now, David is 15 years old and David is 8 years elder to Jessica. So, we need to figure out that what is Jessica's age. Now, this is a very simple problem, and some of you must have also got the answer. But we need to figure out that exactly what is the process that we do to find the answer. For example, let Jessica's age be X. Now, because Jessica's age is X and we know that David is 8 years elder to Jessica and we also know what David's age is, so can I simply write that X years plus 8 is going to give me what? 15. Because I know that Jessica's age plus 8 years is going to give me what? David's age. So when I solve this, X will come out to be what? 7 years. So that means that Jessica is nothing but 7 years old. So we found the answer using these equations. But before we move further, just tell me one thing, that what is the basic thing that we require to solve this equation, or in fact to make these equations in the first place? Those were what? Those were numbers. We know that 7 plus 8 is 15, right? And that is exactly what we found out here when we kept 7 as x, right? So this is the equation that we made from which we found out Jessica's age. Now, as you can see that these numbers are so important. We have seen that they help us in counting, they help us in equation, and there are so many things. Like mathematics cannot stand without numbers, right? And not only mathematics, physics, chemistry, all the other subjects, they require calculations. Therefore, numbers are so important. So as we now know that what are numbers and why they are important, let's see what all we are going to study in this chapter. So in this chapter, we are going to study about numbers, about Euclid's division lemma, about the division algorithm, also about fundamental theorem of arithmetic. Then we'll move forward to prime factorization, HCF and LCM, and finally to the decimal expansion of rational numbers. So let's begin. First of all, let's define numbers. Now we have understood that what are numbers, why they are important. So let's just give it like a very professional definition, as I must say. Now a number is an arithmetic value which is used to represent the quantity, and it's also used in making calculations. Simple, right? Now number can be split into various categories. We know that there can be natural numbers, or there can be whole numbers, even or odd numbers, then prime or composite, rational, irrational, and finally the aggregation of all of them as real numbers. Now you people have studied about these numbers in the previous classes, right? But do not worry if you do not remember one or two or maybe 4-5 types of numbers. Let's just do a quick recap of what all these various types of numbers are. To begin with, let's see that what are natural numbers. Now natural numbers are numbers that start from 1 and they go till infinity. Infinity is like which cannot be defined. And these numbers need to be like what? A whole of something. Which is to say that natural numbers cannot be 1.5. This cannot be a natural number. Natural numbers are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 and so on. All these numbers are what? All these numbers are natural numbers. Similarly, if I talk about whole numbers, then whole numbers are nothing but when I add 0 to natural number. So when I'm going to add 0 to natural number, that is going to become what? A set of whole numbers. Simple, right? Similarly, when we define even and odd number, what we see? Now, even numbers are numbers which can be divided by 2. Correct? And all the other numbers are going to be what? Odd numbers. Now, 4 can be divided by 2, 6 can be divided by 2, 8 can be divided by 2, 10 can be divided by 2, and 2 itself can be divided by 2. So that means that all these numbers are what? All these numbers which can be divided by 2, they are your even numbers. Whereas all the other numbers which cannot be divided by 2, for example 3, 5, 7, 9, 11, 13, 15 and so on. All these numbers cannot be divided by 2 completely. So these numbers are what? These numbers are odd numbers. Now let's move on to integers. So what are integers? Can anyone tell me? Integers are nothing but they are just the negative part and the positive part plus the 0. That is, integers are when I take a set of whole numbers. So it's going to be 0, 1, 2, 3, 4, 5, 6, 8 and all these till infinity. And then I also take negation of those numbers. That is the negative aspect of those numbers. So if I talk about 1, there has to be a negative 1. If I talk about let's say 5, then there has to be a negative 5. So in integers, there has to be a positive set of numbers and on the same, there has to be negative set of numbers as well. But besides your positive and negative set of numbers, we should also have what? 0, which is neither positive nor negative. So combining all these three aspects, that is your positive numbers, your negative numbers and your 0. So combining all these three gives us what? Integers. So these are what are integers. Now let's quickly talk about that what are prime numbers and what are composite numbers, right? So what are prime numbers? Prime numbers are nothing, as you people know, that they are the natural numbers that are greater than 1 and which are divisible by 1 and the number itself. For example, when I talk about 2, about 3, about 5, about 7, about 11. Now what is common in all these numbers and so on itself? The property that is common to all these numbers is that these numbers cannot be divided by any other number except for 1 and number itself. Now we all know that 1 can divide any number. So that means the only property of prime numbers which is important is that these numbers cannot be divided by any other number except for numbers itself and 1. That is all. And all the other numbers which can be divided by 1, by numbers itself and by other numbers. For example 4. Now 4 can be divisible by 1, by 2 and by 4 itself. So it is what? It's going to be a co-prime number. Whereas when I talk about 3, 3 is only divisible by 1 and 3. So it's what? It's a prime number. Whereas on the same, like on the other hand side, if I talk about 6, 6 is divisible by 1, 3, 5, 1, 3 and 2. Also by 6. So this is what? This is going to be what? Co-prime number. So I hope you people now know that what are natural numbers, what are whole numbers, even number, odd, integers, prime and co-prime numbers. So let's move on to the next concept of what are rational numbers and irrational numbers. So when we talk about rational numbers are nothing but rational numbers are basically of the form p by q. Okay, so p by q form of any number is a rational number. Now, whenever I talk about P by Q form, then it should always imply what? That Q cannot be equal to 0. Why? Because if in P by Q, Q equals to 0, then this will be what? P divided by 0. And P divided by 0 is going to be what? Nothing. Like, it cannot be determined. This cannot exist. So therefore, whenever we talk about rational numbers, then rational number is of the form P by Q, where Q cannot be equal to 0. Correct. Now, let me tell you one trick. Now, this is like a very, very good trick to actually find out that what are rational numbers. So, there are two ways to actually find rational numbers, okay? So, the first is if any number terminates after a definite decimal expansion, then that is definitely a rational number. For example, let's take an example of 25 by 4. Now, when I solve 25 by 4, I'll get 6.25. Then that means this number is actually terminating, or I would say this number is ending after a definite set of numbers after your decimal. So that means this number is going to be what? Your rational number. And the second trick is what? Second trick is when your number is non-terminating but it's repeating. Like for example 0.33333 and so on. Now this number is not terminating. That means this number is not ending, but it's repeating. That means the digits are repeating itself. So this is going to be what? This is going to be your rational number, right? So what all we studied till now? We studied about what are your natural numbers, your whole numbers, your even numbers, odd numbers, integers, prime and composite number. And we also understood that what are rational numbers. So what are rational numbers? They are of the form P by Q, where Q is not equal to 0, and a trick to actually find out that whether a number is rational or not. What we need to do. First of all, if they are terminating after a definite set of numbers, then that means they are what? Your rational numbers. And secondly, if they are not terminating but they have repeated values, then they are what? They are rational numbers. Now let's move on to the irrational numbers. That is, what are irrational numbers? Now when we talk about irrational numbers, so these are the ones that are non-terminating, non-repeating one. That is, for example, if I take example of 43.82747290673 and so on. Now, as you can see that this number is non-terminating. Non-terminating means this number is not ending. So this number is not ending and the digits in this number is not repeating like it was repeating in 0.333, right? So the digits are also not repeating in this number and this number is non-terminating. So all the numbers in which the digits do not repeat and those numbers are non-terminating, they form the category of what? Irrational numbers. Now if you want to actually plot rational numbers and irrational numbers on number line, you can see this diagram. That all these numbers minus 4.5, minus 2.5, 0.33, 1.7, 2.9, 4.1, all these numbers are what? All these numbers are rational numbers. Why? Because they either terminate or whenever they are non-terminating, they are actually repeating. And all these numbers, that is root 2, root 5, pi, these are the numbers which do not repeat themselves and they are what? They are non-terminating. So all these numbers are going to be what? Irrational numbers. So now let's see how all these different domains of numbers are connected and how we can actually present them. Now, when we need to present these numbers, then we take the help of what? We take the help of real numbers. Now the point is that real numbers is actually the aggregation of all those numbers. That is, we know that your natural numbers are a part of whole numbers because natural numbers are what? 1, 2, 3, 4. And whole numbers is what? 0 added to natural numbers. So like here there has to be natural numbers, then your whole numbers, then the whole concept of whole numbers plus your negative numbers will give you what? Integers. Now all the integers plus all the decimal values are going to give you what? Rational numbers. And all the non-repeating and non-terminating numbers, that are the irrational numbers, will form a separate piece. And combining rational and irrational numbers, we will get what? Your real numbers. So this is exactly what is real numbers. I hope you people have understood about the numbers. So let's just see this flowchart quickly before we start with the next concept. So we know that real numbers are divided into two segments. that is rational numbers and irrational numbers. Your rational numbers are divided in two segments, that is your fractions and your integers. Now integers can either be negative or your whole numbers, that is your positive plus your 0. Right? Now whole numbers can be what? Whole numbers can be your 0 and your natural numbers. So I hope you people understand this flowchart. So you can just take a screenshot of this, or you can jot these things down into your notebook so that you remember after a couple of days itself. Now we know a basic knowledge of numbers. We have like a basic, like rudimentary understanding of what the numbers are. So let's start with what is lemma, what was Euclid's lemma, and how all the other things work in this chapter. Alright, so let's talk about what is Euclid's division lemma. Now before explaining that what actually is Euclid's division lemma, we need to understand that what basically is lemma. Okay, so what is lemma? We need to first of all understand this. So the thing is that lemma is nothing but lemma is a proven statement which is used to prove another statement. For example, if I will say that the sun rises in the east, so I know that the sun rises in the east. Now one of the statements which can help in proving the statement will be that the sun sets in what? West. So this forms a lemma. Why? Because it proves the statement, right? It's used in proving the other statement, because obviously if the sun is going to rise in the east, it's going to set in the west. So each statement of this statement, statement which I have just told you, that the sun rises in the east and sets in the west. So these form what? Two statements. So each part of this statement actually explains the other. So it's going to be what? Lemma. So in easy terms, what is lemma? Lemma is nothing but a proven statement that is used to prove something else. And this is why there is Euclid's division lemma. Because there is this statement that was given by Euclid that given positive integers a and b, there exists unique integer q and r satisfying this. Now you people might be thinking that what is this? It seems very, very, I would say, difficult to understand. But trust me, it's easy. Let's see how. Suppose I have to divide 7 by 3. So it's simple. 3 into 2 is 6, and when I do the division, 1 is going to be my remainder. Now we all have done this, right? Now there is this one question of mine. Can I convert this division into what we are studying? That is, can I convert this division into this? That is Euclid's lemma. Why not? What you need to understand is that 7 is your dividend here. Okay. What is dividend? Dividend in this equation is a. That is, a is nothing but 7. Similarly, 2 here is what? 2 is your quotient. That is, q is nothing but 2. 3 here is your divisor. So b is nothing but 3. And 1 here is your remainder. So r is nothing but 1. So when I am going to convert this division into Euclid's lemma, I can simply write that 7 equals to 3 times 2 plus 1. Now there is this bar on the r, which is to say that r can be greater or equal to 0, but it has to be less than b. Like for example, in this case we have 1. So 1 can be greater or equal to 0, but it has to be what? It has to be less than 3, right? So that means if I have r here, r has to be greater or equal to 0 or less than 3. So the values of r can be 0, 1, 2. It cannot be 3, right? And in this case it is what? It is 1. As simple as that. Okay. So let's move forward and solve one question to understand this. So what we need to do here is we need to show that the cube of any positive integer is either of the form 9m or 9m plus 1 or 9m plus 8. Now let's suppose there is a number a, and we know by Euclid's division lemma, which we have just studied, that a can be written as what? B cube plus r, where r has to be greater or equal to 0 and less than b. Correct? Correct. Now, if your b is 3, let's say your b is 3, right? So a equals to 3 cube plus r. Now I'm not saying that b can always be 3, but I'm just assuming for the sake of this question that b is what? B is 3. Right. So what we need to do is, we have assumed that b is nothing but b is what? 3. Now, we know that r can either be 0 or anything, but it cannot be b. It has to be what? B minus 1. So it has to be from 0 to what? Like closed bracket 0 to open bracket b. What is closed and open? Closed is when I include the number, and open is when I do not include the number, but I include the number that is just to the left of that number. So that means r can be 0 and r can be b. Now because b is 3, so r can be between what? 0 and 3. So r can be what? R can be either 0, 1 or 2. So I'm going to substitute the value of r one by one and see what my result can be. So let's suppose r is 0. If r is 0, then my number a is going to be what? 3q. Now my number is what? 3q. So what the question is saying is that I need to find the cube of any positive integer. Now I know that a equals to 3q. So cube of a is going to be what? 3q cube. So this is going to be what? 9q cube. Correct. And can I write 9q cube as m? So I've just replaced that with m. So it is of the form what? 9m. Similarly, if I'm going to write r equals to 1, then it's going to be what? It's going to be that a equals to, from this equation, see this equation, a is going to be what? 3q plus 1. Similarly, if I do the cube of this number, that is 3q plus 1, and what I need to do is, I need to do whole cube of this. So whole cube of this is going to be what? It is going to be, I'm going to write it here, 27q cube. So we just need to do what? A plus b whole cube. So it's going to be 27q cube plus 27q square plus 9q plus 1. Correct. And when I'm going to solve this, can I take 9 as common and write it as 3q cube plus 3q square plus q plus 1. And again, I can take this as what? Let's say I can assume it as m. So I can write it as what? I can write this equation as 9m plus 1. Now before moving forward with this question, I'll just explain you this question once more again. Like what have we done till now? So basically what I'm saying is that I need to show that cube of any positive numbers is of these three forms, that is 9m, 9m plus 1 and 9m plus 8. Correct. So I know that the number can be equals to, like in the form, if I use the Euclid's division lemma, as a equals to bq plus r. Now I know because I need to do cube and there is this number 9 that is coming. So let's guess and let's say that the b number here is 3. So I've substituted b as 3. Okay. Now if b is 3, then the remainder can be what? Either 0, 1 or 2, because the remainder has to be between 0 and 3. Okay. So if I put remainder as 0 in this equation, this is the equation I am dealing with. So if I put remainder as 0, a is going to be 3q. So the cube of this is going to be 9q cube, and I assume that 9q cube is nothing but what? M. So it's of the form 9m. Similarly, when I'm taking r as 1 is going to be what? 3q plus 1. So 3q plus 1 is going to be here. Then I have to take cube of it. I have to apply the identity of a plus b whole cube. When I open it, this is the equation that is going to come. I solve it a little bit. This is the equation that is going to come. And then I just assume that this portion of it is m. So it is of the form what? 9m plus 1. Similarly, on the same ground, I am going to also do for the other way round. So let's see how we can do this. So I'm just going to erase a little bit here. Okay, so let's understand this question. So let's say that r is now nothing but r is 2. So this is going to be what? 3q plus 2, and this is going to be a. So when I take cube, it's going to be 3q plus 2 whole cube. So here also I'll apply the property of a plus b whole cube, and when I'll apply property of a plus b whole cube, I can simply write it as what? I can write it as 27q cube plus 54q square plus 36 cube plus 8. Similarly, I'm going to take what? 9 as common, so it's going to be what? 3q cube plus 6q square plus 4q plus 8. Again, I'm going to assume this value as m, so it will be what? 9m plus 8. So we have just shown that the cube of any positive integers will be either of the form 9m or 9m plus 1 or 9m plus 8. I hope you people have understood this. So let's do one more question on the same topic. Alright, so let's see what this question says. Now this question states that a sweet seller has 420 kaju barfis and 130 badam barfis, and she wants to stack them in such a way that each stack has the same number of sweets and they take up the least area of the tray. What is the maximum number of barfis that can be placed in each stack for this purpose? Now this question can be solved with the help of error and trial, right? But to do it in a very systematical way, we need to find the HCF, that is the highest common factor of what? 420 and what? 130. Now the thing is that you do not need to worry what is HCF right now if you do not know how to find it, because this question can be simply solved with the help of Euclid's division lemma as well, and HCF can be calculated with that as well. For example, we know that 420 is nothing but 130 times 3 plus 30, correct? And 130 is what? It is nothing but 30 into 4 plus 10. So when I talk about 30, 30 is going to be what? 10 into 3 plus 0. So the HCF is going to be what? 10. Now, wait a second. Just wait a second. Give it a break. Pause the video and see what did I do in this. What did I actually do and what are the steps that I followed. And if you people do not understand what I do, let me tell you now. So we know that in Euclid's division lemma, the equation goes as A equals to BQ plus R, where R can be greater or equal to 0 but less than B. Now I wanted to find out HCF of 120 and 130 because I want to find out what the maximum number of barfis that can be placed. Okay, so that means I need to find out the highest accommodating factor which can be there. Okay, and the highest number of barfis that could be put. So if I say that there are highest number of the barfis that can be put, then I need to figure out that the remainder of those barfis which are there, which are stacked there, needs to be what? 0. And for the same we have used what? Euclid's division lemma. Now the thing is that when I see 420 and 130, I can immediately say that 420 kaju barfis means 130 badam barfis into 3 plus 30, correct? So this is what your badam barfis and this is what your kaju barfis. So kaju barfis is nothing but 130 into 3 plus 30. So that is going to give the total amount of kaju barfis. This means what? This means that when I accommodate 420 and 130, there is still a remainder of 30, right? So now what I'm going to do, I'm going to make the next equation as this. That is 130 is going to be here. So I have to divide 130 by 30, that is the remainder here, and then the quotient is going to be 4 and the remainder 10. Similarly, because the remainder is not 0, we just need to continue the division. And for the sake of that division, we need to divide this 30 with the 10, that is the remainder, so that what? The remainder of the final equation came out to be what? 0. Now, I can literally understand that most of you would be saying that what is going on? Do not worry if you people do not understand this. Let me explain it to you in a better way. Now, this is going to be a short way of doing it. But the long way of doing the same question, if you people are not able to understand, is what? Now, I need to divide 420 kaju barfis with 130 badam barfis because I need to find out that what is going to be the maximum accommodating factor, which is to say that I have to accommodate all of these barfis maximally. Okay. So, for this purposes, we need to use what? My division algorithm. Okay. So, there is this division algorithm that is there, which I need to figure out. Okay, so you people have done this division algorithm in your previous classes itself. So what you need to do is you need to divide 420 by what? 130. Now we know that 130 times 3 is going to be what? 390. So when I subtract it, it's going to be what? 130. Now, sorry, when I subtract it, it's going to be what? Your 30. So 30 comes up your what? As your remainder. Now this remainder is going to form your what? The next divisor, and your previous divisor will be your dividend now. So when you divide 130 by 30, what is going to come? So it is going to be that 4 times is 120. So 4 becomes what? Your quotient. Then that is your 120. So when I subtract, it becomes what? Your 10. So now your remainder is 10. So now 10 is going to be what? 10 is going to be your, just a second, I'll just erase it. So 10 is going to be what? 10 is going to be your divisor now, and your dividend is going to be what? 30. So 10 times 3 is 30, and the answer is 0. Now give it a thought that in your previous classes you used this technique to find out the HCF, or I would say the maximum accommodating factor, which in this case came out to be 10. But we just did Euclid's division lemma. Can you use Euclid's division lemma and your knowledge of your previous classes to actually find the answer of this question? I've already done it, and those are the equations which I did. So how? 420 and 130, 3 and 30. We can write an equation, that is 420 equals to 130 times 3 plus 30. Now for the next equation, 30 is what? Your divisor, 130 is dividend, 4 is your quotient, and 10 is your remainder. That is 130 equals to 30 into 4 plus 10. Next equation, 10 is your divisor, 30 is dividend, 3 is quotient, and 0 is your remainder. So 30 equals to 10 into 3 plus 0. And the highest factor is going to be what? 10. So I hope you people have understood this question, because I've explained it with the help of Euclid's division lemma, with the help of prime factorization, and how we have actually reached the Euclid's division lemma with the help of prime factorization as well. So I hope you people understood this. Now let's use division algorithm to solve one question to understand that what actually was division algorithm. So if I want to find out the HCF of 135 and 225, so what I need to do? Now there are two methods of doing this question itself. The first method is that, okay, I take 135, and when I'm solving 135, it will be that 3 times 45, then 3 times 15, then 3 times 5, then 5 times 1. Similarly, when I take 225, I can do what? I can take that, it's going to be what? 3 times 75, then 3 times 25, then your, okay, 75, 25, then your 5 times 5, and your 5 times 1. So that means between your 225 and your 135, there are a few common numbers, and those few common numbers are going to be what? 3 and 3, then again 3 and 3, and then 5 and 5. So that means the HCF is going to be what? The HCF is going to be 3 into 3 into 5, that is nothing but 45. Now this is method 1 of solving the question, but we are not going to use it today. We are going to use the other method, that is your prime factorization method. So let's erase it all and understand how we can do prime factorization to solve it. If you people know how to solve prime factorization, then do just pause the video and solve the question on your own before seeing that how I do it, because it will be a better format of learning them. Okay, so prime factorization is going to be simple. It's going to be that we need to divide 225 by 135. So it's going to be what? 135 ones are 135, which is going to be 90. So 90 will be your divisor now, and 135 is going to be what? Your dividend. So 90 ones are 90. When I subtract, it's going to be what? 45. So 45 is going to be my divisor and 90 is going to be my dividend. So 45 twos are 90, 0. So that means this 45 is going to be what? My HCF. As simple as that. And you know, this is exactly what we did in the previous question itself. So this was exactly what we did in this question itself. That is how we found out the HCF, and this is exactly how we solved this question as well. So now I'm pretty sure that you people must have understood everything in like detail. So let's move forward. Okay, now we need to understand the concept of the fundamental theorem of arithmetic. Alright, so let's understand that what is fundamental theorem of arithmetic. So fundamental theorem of arithmetic states that every composite number can be expressed, or I would say factorized, as a product of primes, and this factorization should be unique apart from the order in which the prime factors occur. Now the thing is that this is one of the most easiest concept ever, and you have done this like I would say a billion times before. So what is this? Let's understand. And I would say that let's understand with the help of question itself. Okay, so let's say that you need to solve a question that is 32760. Okay, so 32760. Now basically the fundamental theorem of arithmetic states that if I have a composite number, I just have to express that composite number in terms of my prime numbers. And this is exactly what the fundamental theorem of arithmetic is all about. Now, if I want to express my composite number as a prime number, then the simplest thing I can do is prime factorization. Okay, so it's going to be what? 2 times, if I divide it by 2, because there is 0, so it's an even number. So 2, it's going to be what? 16380. If I again divide it by 2, it's going to be 8190. Then again by 2, it's going to be 4095. By 3, it's going to be 1365. Then again by 3, it's going to be 455. Then again by 5, it's going to be 91. Then by 7, it's going to be 13. And 13 ones are 13. That means I can express 32760 as 2 to the power 3 into 3 to the power 2 into 5 into 7 into 13. And this is how I express 32760. Now some of you might be asking, if you people do not know already, that why did I write 2 to the power 3? Now 2 to the power 3 means 2 into 2 into 2, correct? And as you can see, there are 3 2's. Similarly, 3 to the power 2 means 3 into 3, because there are 2 3's. And then 5, 7, and I have 13. So into 13 should be here. So this is how I am going to express 32760. Now when I go back to the concept itself, and it's what? It is basically that 2 times of 546 is what? 1092. So when I do 1092, it's going to be 2 times of 546 is what? 1092. Then 3 times of 182 is going to be 546. Then 2 times of 91 is 182. And lastly, 7 times of 13 is going to be what? 91. And 13 times 1 is what? This. So 1092 can be written in the form of 2 to the power 2 into 3 into 7 into 13. So this is how we can write 1092. Alright, I hope you people have understood everything we have discussed so far. Now let's come to another topic of prime factorization, but we are going to understand this topic while solving a question itself. Now, you people must be wondering that we have just done prime factorization. Yes, this is what is prime factorization. So let's quickly take one more example and wrap this topic. Alright, so the question states what? The question states that I need to express 18 using prime factorization. This is such a simple problem. 18, I can write 2 9s are, 3 3s are, and 3 1s are. So 18 can be written as what? 2 to the power 1 into 3 to the power 2. As simple as that. Done and dusted. So let's move on to another question now. So the next question states what? The next question states that we need to find what? The HCF and LCM of 6, 72 and 120. Now if I do of 6, then 6 is going to be that 2 times 3 is 6, 3 times 1 is what? 3. Similarly of 72 if I do, so I can simply write that 2 times 36, then 2 times 18, then 2, 9, then 3 times 3 and 3 times 1. And similarly if I do of 120, I can simply say that 2 times 60, then 2 times 30, then 2 times 15, then 3 times 5 and 5 times 1. Now I need to figure out what? I need to figure out the HCF and LCM of this. Now what is going to be the HCF? HCF is the highest common factor. So what's going to be the highest common factor? 2, 2 and 2 are common. 3, 3 and 3 are common. So that means the HCF is going to be what? It's going to be 2 into 3. Alright, so this is going to be what? HCF, that is HCF is going to be 6. Whereas what is LCM? LCM is the lowest common multiple. So the lowest common multiple is going to be what? 2 is what? 3 times. That is 3 is how many times? 2 times at max into 5. Which is to say what? That at max 2 is how many times? 3 times. 1, 2, 3, 1, 2, 3. Alright. So in one of this 2 is at max how many times? 3 times. So 2 to the power 3 into 3 is how many times at max? 2 times. 3 times 2 and 5 is how many times at max? 1 time. So 2 to the power 3 into 3 to the power 2 into 5 to the power 1. This is going to give me what? This is going to give me 360, which is nothing but highest common multiple. So 6 here, sorry, lowest common multiple. Now 6 here is the HCF, that is the highest common factor. So it's a factor. Remember that it's a factor. Whereas 360 is the LCM. So it's what? The lowest common multiple. So remember, this is a multiple. So this 360 is the lowest multiple, whereas this is a factor. Okay, so let's move to another topic, that is expansion of rational numbers. So this is, I would say, a comparatively easier topic. So let's quickly understand this and move on to the next concept. Alright. Now the thing is that the decimal expansion of every rational number is either terminating or non-terminating repeating, and the decimal expansion of every irrational number is non-terminating, non-repeating. And this is exactly what they have told. They have said that decimal expansions can be of two types. Either they are terminating or they are non-terminating. Okay. If they are terminating, then we say that that is a rational number. If they are not terminating, then either they are repeating or they are not repeating. If they are repeating, then they are rational numbers. If they are not repeating, then they are irrational numbers. And this is exactly what I told you when I told you the tricks of how to find out the rational numbers. That is, if you have a repeating non-terminating decimal expansion, then that is your rational number. Or if you have a terminating decimal expansion, then that is your rational number. Similarly, your irrational number is going to be if you have a non-repeating, non-terminating expansion, then that is going to be what? Your irrational number. Moving forward, alright, so there is this theorem. So let's quickly understand this theorem and solve a few questions to wrap the chapter with a bang. Okay, so this theorem says what? This theorem says that if x is a rational number whose decimal expansion terminates. Now the decimal expansion actually terminates, okay, and it is what? A rational number. Then x can be expressed in form of p by q. We know that every rational number can be expressed in form of p by q, where p and q are what? Co-prime numbers, that is, they do not have anything common in between. And the factorization of q is of the form 2 to the power m and 5 to the power n, where m and n are non-negative integers. So this is your theorem 1. Now, before understanding this theorem with the help of a question, I will quickly state one more theorem, which is, I would say, like a part of this theorem itself, and then we can solve a question to understand these two theorems in combination. So the next theorem states that let x be equal to p by q, that is like a rational number, where p and q are what? Co-primes, and it's what? A rational number, such that prime factorization of q is not of the form. So q is not of the form 2 to the power m, 5 to the power n, where m and n are non-negative integers. Then x has a decimal expansion which is non-terminating, repeating, that is recurring. So basically the basic difference between these two theorems are that in the first one it's saying that q is of the form 2 to the power m, 5 to the power n, and When q is of the form 2 to the power m, 5 to the power n, then the decimal expansion terminates. Whereas it says when q is not of the form this, then the decimal expansion does not terminate and it's recurring. Which is to say that it says that if q is the form 2 to the power m, 5 to the power n, then it terminates. So it terminates. And if q is not of 2 to the power n, 5 to the power n, then it does not terminate. And it's what? Because it's a rational number, so it will be what? Repeating. So it will be what? It will be your repeating. So I hope you understood these two theorems. So let's solve a question to understand this all. Okay. So first of all, we need to find the decimal expansion of 3 by 6. Okay. So 3 by 6 is what? 3 by 6 is basically that we have 6, 3. So it's going to be what? 0. Okay. So if I write 0 point, so because of this point I can put like a 0.0 here. So 5 here. So it's going to be what? 3.0 again. And it's going to be what? 0. Correct? Correct. That means I can write this as that your 3 can be written as 6 into half plus 0. Correct? This is the equation which I have solved here. I hope you people understood this. Now here you can see that the quotient is 0.5 and the remainder is 0. And the rational number is what? 3 by 6. Where 6 is what? 6 is 2 into 3. Okay. So that means it's a terminating decimal. Okay. So this is going to be what? This is a terminating decimal as we have said. Now the next is that we need to express 5 by 13 in a decimal form. Now this is also very, very simple if I need to do 5 by 13. So if I'm going to do like a division and if I'm just going to solve it. So it's going to be 13, 5. So I'll just put like a 0 point here so that there can be like a 0 accommodating. So it can be 3 times 13, 9 and it will be 11. So because there is like a 0, I can put a 0, then there is going to be this 8. So it's going to be 104, then it's going to be 6 and there is a point, so I can put a 0 and then 4 times 52, it's going to be 8. I can again put a 0 and it's going to be 6 times 78 and it's going to be 2. I can again put a 0 and it's going to be 1 times 13. I'm going to solve it here. So 13, and when I like subtract 12 this, I get 7. I can again put a 0 and it will be 17. So it will be 5 times and it will be 65. It will be 5. I can again put a 0 because of the decimal. So it's going to be 50. Then if I'm doing the long division, it's 3, then 50 and it's 39. So it's going to be 11. I can again put a 0 because of the decimal. So it's going to be 8 here and it's going to be 104. It's going to be 6. I can again put a decimal, that is 0. Then finally for 4, it's going to be what? 52. And finally when I do this like subtraction, the answer is going to be what? 8. So I can write this whole as what? I can write this whole as that 13 will be equal to 50 into 0.384615384 plus 8. So this is going to be what it is. Now hence we can see that the quotient that is given, that is 0.384615384, pretty long quotient, and the remainder is not 0. So notice that the number 384 after the decimal is actually doing what? It's repeating, because 384 is here and 384 is here, right? So it's actually repeating. Hence we can say that 5 by 13 gives us what? A non-terminating recurring decimal expansion, as I have told you in the theorem itself. And this can be written as what? This can be written as that 5 by 13 is nothing but 0.384615. And because this whole term is repeating, so I'll just put a bar on top of it. So this is what was the meaning when I was telling you that what if q is going to be 2 to the power m and 5 to the power n. So what is going to be the verdict then? And if q is not equal to 2 to the power m and 5 to the power n, so what is going to be the verdict at that point? and we have seen 2 questions and we have seen how to do it. This one was a little bit more explanatory question, I would say, and I hope you understood the concept very well and enjoyed the session, because I enjoyed teaching, so I hope that you also enjoyed understanding it. So I hope you people have understood what are real numbers and everything in and around them. We will practice some questions in the next lecture to level it up. Till then, you can go to EduRev and you can attempt the test to understand this chapter in depth. You can unlock all the logged videos, documents, tests for class 10th with EduRev Infinity Plan and ACER exams at less than 80 rupees per month. Thank you.